What will be the value of de Broglie wavelength when a neutron in thermal equilibrium with a heavy water at temperature T and mass m? It's known that at thermal equilibrium, the average energy in the water can be written as 3 over 2 kT. Similarly, the average energy in terms of momentum can be written as p square divided by 2m. So both are representing energy only. So we can write 3 over 2 k times t is equal p square divided by m. So this is about the energy. But here the question is regarding the wavelength. It's known that lambda, the de Broglie wavelength, is nothing but h divided by p. So we know h is a Planck's constant. We need an expression for p now. So from the relation of energy, we can write p square is equal 3 kT times m when we are cancelling 2 on both sides. Now we can write P is equal root of 3 kTm. So we have a value of P now. So we can write lambda is equal h divided by root of 3m kT will be the wavelength of a neutron. So the correct answer here is option A.